All right, lesson 6-1, ratios. You have made it to chapter 6, which means bring your calculator from now on. You may use your calculator for chapter 6, 7, 8, 9, 10, 11, and I don't think we're going to do one lesson from 12, and you can use it for that too. So bring your calculators from now on. Our goal today is I can write ratios as fractions in simplest form and determine whether different ratios are equivalent. These are ratios. A ratio is a comparison of two numbers or two quantities by division. This is how they're written. 3 to 4, 3 to 4, or 3 to 4. They're all read as 3 to 4. Notice this one looks like a fraction. It could also be written like that. We don't call it 3/4, we call it 3 to 4 when it is a ratio because it's comparing two different groups. This bottom or the second number doesn't necessarily mean what it's out of. It's just saying one group has 3, one group has 4, comparing those things. So for example, we've got a ratio of green fish to orange fish. With ratios, order matters. So when it says green fish first and orange fish second, the first number should represent the green fish. So the first one would be 2 green fish, and the second one is how many orange fish we have. It looks like 5. That's one way to write it. I could write it with a colon like that, and I could write it as a fraction like that. Most of the time we're going to be using the fraction version because it's going to be the easiest one to work with. So whatever one you like for this lesson, but beyond this lesson you're probably going to want to write your ratios in fraction form. Here's some more fish. So here I've got black fish to red fish. Again, black fish, that number has to go first. So it should be 2 to 3 or 2 to 3. On this fish tank here, I have 1, 2, 3, 4 black fish and 1, 2, 3, 4, 5, 6 red fish. So it's 4 to 6. What do you notice about 2 to 3 and 4 to 6? What I notice is that they are equal. Okay, so basically if I took these fish and another tank of it, or in other words I multiplied that by 2, I would end up with this. These we call equivalent ratios. Equivalent ratios form a proportion that you're going to be learning later in this chapter. But so basically it's just basically saying two equivalent fractions. However, this is considered a ratio because it's not 2 out of 3, it's 2 compared to 3. The 2 is representing black fish, the 3 is representing red fish. There's nothing representing the whole group, and that's just the difference between a ratio and a fraction. So you can see that these two things are equal. We've already known that 2/3 and 4/6 is equal. Here are some ratios written as fractions that we want to find some more equivalent ratios for. All you need to do is take this original one and multiply it by anything. So I could multiply it by 2. I like to choose easy numbers. So then on the top I'd get 2, and on the bottom, I'm going to multiply that times 2, and I get 8. 2/8 is equivalent to 1/4. I could multiply it by 10 and get 10/40. I could multiply it by 5 and get 5/20. I could go on and on and on. 7/8. What could I make out of that? I could multiply that one by 2 on the top and 2 on the bottom. When I do that, I get 14/16. You try a few. Fill in at least 2 more things that you could make as an equivalent ratio to 7/8. Go ahead and pause and do that. Okay? Next, it will give you things that say like, determine whether the ratios are equivalent. What that means is just draw them both out as ratios and then see if they can be equivalent. So I'm going to write this out. 12 out of 20 doctors. So 12 out of 20. This time it is talking about a whole group, but that can still be a comparison. It's still a ratio. And 6 out of 10. There's 2 ways of solving this. One way is to just look and see, can I go from one group to the other and do the same multiplication problem or same division problem? So here I notice if I'm going from 12 to 6, I divided by 2. Did I divide by 2 to get from 20 to 10? Yeah, I did. So these are equivalent ratios. I would write, yes, they're equivalent. I can also look this way and say, oh, that's multiplied by 2. If I look this way and multiply by 2 and that also works, then the answer is yes. But there's one more way of doing this. You can multiply on the diagonals and say, okay, 20 times 6 is 120. And 10 times 12 is 120. And when these two numbers are the same, that means that yes, they are equivalent. Let's try it for this one. So it says $4 for every 16 ounces, or $10 for every 40 ounces. So I would look at this one and say, this is a lot harder for me to just say, did I multiply by the same thing? It's really difficult to tell. So instead, I'm going to multiply this way and say, 16 times 10 is 160. 40 times 4 is 160. Those are the same number. Since I got the same number, then yes, they are equivalent. I don't have an example of when they're not, but basically it's going to be when these numbers end up being different when you multiply. All right, you're going to have a lot of problems like this in your assignment. This you'll also see on your next test. It says use the chart, write the ratio in simplest form. So I'm looking for students to parents. I'm going to look for the number of students, which is 225, and the number of parents, which is 20. Now the difference between a fraction and a ratio is ratios you never write as mixed numbers. So this is always going to stay a fraction, even though the first number is bigger than the second number. I do simplify them though, just like I would simplify a fraction. So I'm going to divide the top and the bottom. It looks like I can divide them both by 5. Let's do the easy one first. The bottom would be 4. The top, well, 200 divided by 5 is 40. And 25 divided by 5 is 5. So put them together, you get 45. That's simplest form. Buses to parents. There are 5 buses. There are 20 parents. I can again simplify by dividing both the top and the bottom by 5. On the top I get 1. On the bottom I get 4. 1 to 4 is my answer. Pause the video and try these problems. Okay, for pigs to goats, you should have gotten 10 to 50 and simplified that to 1 to 5. Ducks to animals, you should have gotten 12. And animals would mean all of these are animals, right? So I'm going to add them all together. Let's see, 50, 60, 70, 80, 98, or sorry, 92. Let me do that one more time to make sure. 20, 30, 40, 50, 60, 70. Yep, 92. I'm going to divide those in half because I know that they're both even, so they can divide by 2. I get 6 on the top. I get 46 on the bottom. Looks like I can divide by 2 again, so you have 3 on the top and 23 on the bottom, and that's as simple as I can get, 3 to 23. All right, time for your NICU check. Good luck.